We are now going through Objective 3, creating an unbiased estimate of the population variance. This is the third key factor that you need to know so far. So recall the situation that we're in right now. We have a situation that we're currently working with where our population mean which referred to as mu, is known or given, but the population standard deviation which we refer to as sigma is unknown. Since our goal of all of these statistical processes is to know whether we have a sample whose data is outside of the normally expected distribution, for example, we're looking to see if our sample is located in one or both of these tails. We have to know what is the spread of this distribution that we're comparing it with. And if this is unknown, then we can't solve our statistical problem. So the standard deviation refers to our spread, and all of this that we're doing right now is going to be in step 2 of our process where we describe the characteristics of the comparison distribution. So what is our solution to this problem? Our solution is going to be, we're going to estimate the population spread or standard deviation. And remember, standard deviation is just the variance, the square root of the variance. And so we're going to estimate the population spread from the spread of the sample. We know we can figure out the spread from that because the sample is just the scores that we've accumulated. So let's figure out how to estimate the population spread based on the spread of a sample. In order to do this, then you'll recall that our original formula for calculating the standard deviation for a bunch of data sets was simply, we take the sum, remember that's our sum figure, of all the deviations squared. So we take the sum of all the deviations squared. And remember, the sum is, the deviations are just each score, x, minus the mean for that sample. This is what we mean by deviation. And we used to divide by n. So it's like taking the average of all those deviations, and then we would just take the square root of all that to get the standard deviation for the sample. So this is this formula for standard deviation. Now we have to change it though, because if we just use this and said that this is our sample, and so we'll assume that's the standard deviation for the population, that wouldn't be quite right because we're using a relatively small number of data points. And so we're going to have a weaker inference. So we can still draw an inference, but we have to do it with caution. So we're going to use the exact same formula now, exactly the same, except we're estimating. So we no longer call it standard deviation because we're estimating. We're just going to name it S. It still stands for standard deviation, but it means we've estimated. The formula is exactly the same. We're still going to begin by taking the sum of all those squared deviations, which is x minus m. This still refers to deviations. Each score minus the mean. We're going to square it. This is the big difference. we're going to divide by n minus 1, which you know from your previous work is the same as degrees of freedom. And so in order to calculate the standard deviation, to estimate the standard deviation for a population, we need to adjust our formula in this one simple way. Now, instead of going all the way down to the standard deviation, we can stop at just calculating the variance. You'll recall that variance and standard deviation are the same. If you know one, you can always know the number, because the variance is going to be the squared standard deviation. I'll just write SD here. And we know that the standard deviation is going to be the square root at the square root of the variance. In fact, sometimes we even write them, this variance in your book is often just written as S squared or SD squared or sigma squared. So all of these symbols just are another way of saying variance. They're synonyms. They mean exactly the same thing as variance. So keep that in mind. When you see S squared, all they're talking about is variance as opposed to standard deviation, but they mean just the same thing. So let's look at some data points. In your very first guided practice problem, we have these sample scores, 23, 24, and so forth. And I'm going to copy them and place them into our whiteboard. There we go. So let's go ahead and work this out. Here are our sample scores: 23, 24, 25, 26, 27. Let me write all of those down. There's quite a few of them. 23, 20. Yeah, it's not necessary for me to write them all down because they're right there. So let's just use the ones as they're written there. So it looks like if we're going to apply our formula, we're going to have to start with a few basic steps. The first thing we're going to have to start with is figuring out what the mean is. And you'll recall that the mean for the, let me get that erased here. You'll recall that the mean is just, first thing we need to do is the mean. And the mean is just the sum of all the values divided by n, the number of values. And so let's calculate the sum of our values first. And so the sum equals 23 plus 24 plus 25 plus 26 plus 27 plus 34 plus 16 plus 21. And if we add all of that together, we get equals 196. The next step is to divide by n. So we actually, if we're going to write the whole formula, we would write this divided by n, which in this case is 1, 2, 3, 4, 5, 6, 7, 8. So 8 equals 196 divided by 8. I've calculated the sum, but I'm going to erase this word now because now I'm just actually calculating the entire mean. And so the mean equals 24.5. So that was our first step. Now we know the mean for our sample is 24.5. Now we have to figure out the spread. And so we're going to use this formula right here to calculate the spread. We're just going to take the sum of squared deviations. So the spread, I'll use purple here. So the spread And we're just going to stop at the variance here because that's all we need to do, because we know that the spread is the square root of the variance, but we're just going to calculate equals standard deviation equals the square root of the variance. And we're going to stop at variance because that next step isn't even going to be necessary. And so we know that the standard deviation to calculate this equals the sum. So let me go step back. We're just going to calculate the variance. So that's the formula that I'm going to write down here. We're not going to do that last step and write the square root sign. So the variance that we're using to estimate is going to be the sum of all deviations, which is just each score minus the mean, squared. And then remember, this is where the estimating part comes in. We divide by n minus 1, or by the degrees of freedom. So this is actually what we're going to be doing here, dividing by the degrees of freedom. And so to do this, let's calculate all this variance out by hand. And so we're just going to take equals 23 minus 24.5 squared plus 24 minus 24.5 squared plus 25 minus 24.5 squared plus, 26 minus 24.5 squared plus 27 minus 24.5 squared plus 34 minus 24.5 squared plus 16 minus 24.5 squared plus 21 minus 24.5 squared. Lots of work here writing all this out, isn't it? Our next step then is to write those values in. So equals minus 1.5 plus minus 0.5 plus 1.5 plus 2.5 plus 9.5 plus minus 8.5 plus minus 3.5. And all of these are going to be squared. So our next step is to square all of these. And so we get to minus 1.5 squared equals 2.25 plus minus 0.5 squared equals 0.25 plus, and I see I made did I make a mistake here? I did make a mistake because I missed a 25. I missed this 25 when I was writing it down up here. So here is another 0.5 squared. This one should have been down here. There we go. So plus 0.25. I should have counted these 1, 2, 3, 4, 5, 6, 7. I knew I missed one because I only had 7, and this is the one I missed. And so I have just filled it in right here. And now it's recorded right here. This is important because it shows you why the next step that we're going to do. Plus 1.5 plus 2.5 plus 9.5. This is really important. So now what I was doing was just writing down the differences again. So let's go to that next one, which would be plus 2.25. 2.5 squared is 2.25 plus 6.25 plus 8.5 squared minus 8.5 squared is 90.25 plus 3.5 squared is 72.25, excuse me, minus 8.5 squared, plus minus 3.5 squared, which is 12.25. And now if I add all these together, I get what we call the sum of squares, which is 186. And this is our sum of squares. To get our variance then, we just take our sum of squares and variance equals the sum of squares divided by, now we're estimating, so we're going to divide by the degrees of freedom, equals 186 divided by n minus 1 equals 186 divided by 8 minus 1, which is 7. And to get then our variance, that total is 26.57143. Now, I showed you all of this process, and I am going to now show you an easier way to do all of this, and it is to use Excel, and you'll see how much easier it is and how much less likely you are to make mistakes, as I do when I do by hand, because you will. So going back to that original problem, you see that we went through all this work and I made several mistakes solving this problem because it's just a lot of writing and a lot of opportunity for mistakes. And I came up with an answer that I think looks pretty good, 26.57. But because of all that possibility of making mistakes and that tediousness of it, as you know, I prefer to work with Excel. And I'm going to show you how to do it. So if you get your spreadsheet out right now, you'll be able to follow along. So the first thing, what I've provided for you in your work is I've put all of these data points into a spreadsheet. So you can see here in our problem, it has these values, 23, 24, 25, 26, 27, and so forth. And what I've done is I have entered these values already for you into this spreadsheet. Now, I'll make it a little bit bigger for you. And I'm going to jump into a bigger screen. So I'm going to. So here are all these problems. Here's the spreadsheet, and I've made a similar spreadsheet for you for your work. Now, I know what we need to know in order to calculate the variance, and that's what we're doing in problems 3. Here are all those scores, and I've linked them all to an individual. So the first thing I know we need is to calculate the mean. In order to do this, we have to calculate first the sum, because we know that the formula for the mean is the sum of all the values divided by n. So let's calculate the sum. So watch carefully while I do this. If you're following along, you always start in a formula by typing an equal sign. That tells Excel that you're about to enter a formula. Now, I always want you to do these by hand. There are always different and quicker ways to do these, but so that you understand the formula, I want you to always do it step by step. So we know that the mean is just calculated by the sum of all the values divided by n. So let's get the sum. I'll write sum right here. And then Excel will want to know, what do you want the sum of? And so put an opening parenthesis. That means you're about to tell it. And notice when you do this, place your attention up here in this formula bar, because that'll be an easier way for you to keep track of things when you get larger data set. So what do we want the sum of? Well, what we want the sum of really is the cell B2 through B9. That's what we really want. And we could write that out. B2, if we put a colon, that means B9. Put an end parenthesis, and we get the sum, 196. Another way that you could do this, that is the way I tend to use, instead of typing in those cells, I just write equals sum, and I Oops, I need to erase that first, equals sum. And I put the opening parenthesis, there it is up in the formula. And instead of me looking up what the coordinates are, I just click in the cell that's the beginning of the range that I want it to sum. And I just, when I see that little vibrating line around it, I just copy down to the end of the range that I want it to sum and hit enter. And you can see it is typed the same thing. I can put that closing parenthesis. It did B2 through B9 for me. Either way is fine. So now we know the sum and we know how easy it is to figure out the mean. We just take our equal sign. We tell Excel, we want Excel to take the value in B10 and divide it by the number. And we know there are 8 people here. So we could just take equals and we could type in B10 divided by 8, and we'd get 24.5 for the average. The way I would probably do this, that you might try now, is to just let's type in a couple things that we know. We know n, the number in the sample, is 8, so let's type that in. And we know the formula for degrees of freedom equals 8, the number, minus 1. So now I have a couple of values in here that I can just refer to. So another way that we could do this would be to just type in equals. We know it's B10, but I'm going to tell it that by clicking in the B10 cell, this 196 equals B10. I'll type my divided by, and I'll click in the N cell. And click enter. And so, sorry about that. And so it came up with, let's see if my computer runs a little slow when I use my screen sometimes. So here we go, 24.5 again, same thing. So that was the function that I wanted to show you right there. Now, the next thing we have to do is figure out our sum of squares. And to figure out our sum of squares, we need to figure out our deviations. And remember, deviation is x minus m, each individual score minus the mean. An easy way to do this in Excel is to just write the mean in 24.5. There are other ways to do it, but for starters, this might be the easiest way. Now that we've clicked in the cell, we see this green line around it. We're going to copy it. So I'm going to just copy it. And I'm going to paste that value all the way down because it's the same mean for all of them. And now I'll paste 24.5. Now the mean is right there, so I can use it for a formula. I want to tell it to subtract x minus m. I'm going to type a formula, so I'll start with the equal sign. You can see it up here in the formula bar. And I'm going to type equals, and I'm going to just type each score. So the first score is B2. Or I can just click in it and it will type B2 for me. Minus, I know I need C2. I'll just click in it and it'll type C2 for me. There's our formula, equals B2 minus 6.2. And we can enter that formula, minus 1.5. Now, we don't have to type that formula in for every value. We can just copy the formula. Now, because there's a formula there, it'll copy it. And we'll scroll down. And I'm going to use Control V to paste, or I could go up to my home menu here and type and find paste. I use this so rarely, I forget where it actually is. Here's paste right here. So I could use that. And there we go. Now we have all the deviations. We didn't have to do those all by hand. Now our next step we know is to square the deviations. And so we're just going to type in a formula, equals, whoops. And we know that squaring just means to multiply something by itself. So let's just type in, I want to multiply D2, this 1.5 value. So I'll click on it. That's D2, you can see it in the formula bar. In Excel, we use the asterisk. That is when we use the uppercase 8 to show multiplying. So equals D2 times what? Times D2. We could write D2 or just click in it again. Now we have the squared deviation for our first person. To copy that down, we're just going to click on that cell so that green line is around it. We're going to hit copy. You could do that right here and go down to the end of the set that you want to copy for and type paste. Now we have all the squared deviations set for us. Now remember, our next step is to calculate the sum of squares, which just means the sum of squared deviations. So it's the sum of this column. These are our squared deviations. So let's type in equals and let's type in sum. And it's asking us, what do we want to sum? Well, we want to sum E2 down to E9. So we could write that out, or we could just click in E2. And when we get that vibrating line, we just hold our cursor down and drag it down. And you'll see it typed in E2 to E9. We can type our closing parenthesis and enter. There's our sum of squares. This is the sum of squared deviations. Now, this is the only thing that's different in calculating the standard deviations to get the estimated variance. And let's write that word estimated variance, the unbiased estimate of the variance. We're going to type in equals. And we're going to take our sum of squares, but instead of dividing by n, we're going to divide by the degrees of freedom, or n minus 1. And since I already calculated my degrees of freedom, I know it's right here in B14. So let's just type B14, and we get the unbiased estimate of the variance, 26.5743. Now, I will remind you that unbiased estimate of the variance is a lot of words to have to write. And so remember, when we talk about standard deviation, when we're estimating it, estimated standard deviation is written with this italicized S. And so we know that the estimated variance is written with this italicized S, but with that square symbol. And that's a little tricky to do in here. The official way to do a square symbol is to use that caret and then up, and that means S squared. So we could also erase this unbiased estimated variance and just write S squared. And that's all the farther we have to go. We are done with this example.